Okay, so good afternoon, everybody. I'm glad I made it because I came from Amsterdam this morning, and Berlin was rendered more or less dysfunctional today by this downpour. And actually, I could give a talk about it because this is something that has to do with climate change and global warming. I'll spend a few minutes on that. So let me just go to the first. Or to the next, let me see. Does it work? Where do I have to point? Does it have to be? Yeah, I know. Aha, interesting. So, it's all about technology, of course. So, what did I do wrong? Okay. It was turned off. So, let me turn you on now. So, citing the Beatles. Okay, this was an event in 2015. A number of interesting events happened. So we had, of course, the publication of the encyclical by Pope Francis. We had the Paris Agreement. But before, in the year, we had, within a series of Nobel laureates meetings I organized since 2007, we had a very interesting meeting. This is Hong Kong, as you can see. It was about changing climate, changing cities. So clearly this nexus between cities are putting out 70% of the greenhouse gas emissions, but we will also suffer heavily from the impacts of climate change. And so that is a very interesting nexus. I will not talk about that only indirectly today. So I really focus on the structural development of cities and what the geometry of cities may be, also in times of climate change. And this will bring me to a subject I have pursued as a complex systems scientist for 35 years, more or less. I'll come to that in a minute. But before, as I promised, what you are seeing today in Berlin, and you see all over Germany, this very extreme precipitation event is directly linked to climate change in the following way. This is a special weather situation when humid air comes from the Mediterranean, more or less, is moving across southeastern Europe, and then in a huge loop coming back from the northeast, and then it starts raining, in particular in the northern part of the Alps, but also in Saxony and in Berlin here. We call it the so-called Genova cyclone, and it has to do with the jet stream in general, and the jet stream is this ribbon of high winds, 10 to 12 kilometers above the ground, which in general is a very straight ribbon, but it can create so-called planetary waves, or Rossby waves, and once you have such a wave, you can have an extreme event, either a drought or a big flood, actually. And with climate change, the probability rises that you will have more of this actually blocked standing Rossby waves. We call it quasi-resonance. I could spend an hour on that, but you wouldn't understand it, nevertheless. So I will skip that. But it's really true. Because of the retreat of the Arctic sea ice, we have a higher probability that we will have these extreme precipitation situations in Central Europe, for example. And today, it's another one of those events. Okay, so let me talk about the cities, and this has to do with, in the end, with what we call fractal geometry, indirectly, but I come to that later. So, you know, when people started to build cities and later thought about cities and tried to improve cities and sort of redesign cities, there was this eternal quest for what's the ideal city. Also, there are beautiful coffee table books about it where you can look it up. But in particular during the Renaissance, in particular Italian architects, painters, philosophers thought about what would it look like. Some people argue that the closest to the ideal Renaissance city is Pienza in Tuscany, and if you visit that city, it's very nice, very lively and livable place actually. But you see already in 1972, there was this vision of urban gardening, if you like, so this skyscraper, many-story building, but full of plants, so you grow, if you like, an urban forest in a skyscraper. This may come true actually one day, but at that time it was clearly a completely wacky idea, right? And the development was very differently. So, ideal city, people have dreamed of. We can ask the question, and the German Advisory Council asked the question, what would be the ideal city in the times of climate change, in the times of energy crisis, in the times of food crisis, in the times of migration, and so on. I think it's a very important question. I'll give you my answer to that a little bit later. But before, let's look at real cities. So I give you first, so this is an animation I was stealing from the Guardian website, actually. It's an animation showing how, where in particular, and when did the big cities rise on this planet, and I think it's telling a very powerful story, what accelerated in particular the urbanization in the Western world, first in antiquity, then in the Western world, and today we will see this being replicated globally, actually. So let's try to start it. Okay, so you see the planet. And when the history of urbanization over the last 6,000 years, so it's starting with Uruk and places in Mesopotamia, whenever a point flares up, you see a city was founded, and when it turns red, it matures, actually. So take your time as we move through the millennia, and you see it's all focused in the Fertile Crescent. A little bit later, the Indus civilization comes up, and you saw the first point flaring up in China to the east. And so we move towards the early Greek, if you like, cultures here, Crete, and later on in Greece itself, when Rome was founded, obviously. See, look what happens in the eastern part. By the way, now in the Americas, in Mexico, cities were created. And finally, the whole thing shifts to Europe, so we were not the first, if we speak as Europeans. So it goes on, and now you had an acceleration. Now you have the medieval climate optimum, and that's really important. So you see the whole thing accelerates. A lot of cities founded in particular in Germany, in France, in the UK, and so on. So we move through modern times and enter the Industrial Revolution right now. And then you see an explosion. This is the urbanization driven by coal and steel and steam engine and all these things. And this has converted the ratio in the UK as the sort of poster child of Industrial Revolution country. Before 1600 or so on, you had about 20% of the people living in cities and 80% living in the hinterland, and this was completely converted after 150 years. So you have 80% of the people living in cities and 20, for many, many reasons, of course, which I will not replicate. And the same happened when in Germany, and it happened on the east coast of the United States. So you can look. How will this map look like in 100 years from now? Will we have maybe just 100 leading cities who have absorbed all the resources, 100 Singapores, San Franciscos, New York Cities, Londons? Or will the area be covered with sort of points like that, equally spaced? Or will there be a much more subtle structure in the end, which I would argue for? So let's talk about it. So this is the global distribution, but now let's look at the development of a specific city now in structure. So most of the time I will talk about structure really, not the materials used in a city, not about real estate speculation. We heard about that. It was a very interesting panel. I talk about design, about shape, about form, geometry really. Yeah? Because I wasted part of my youth in thinking about fractal dimensions, which is a beautiful subject, completely useless, it seems. But maybe it's not so useless after all, so you can judge for yourself. But I definitely wasted my time on it. So, that is Delhi. And people could argue whether it was ever a city at all in the European sense. So some geographers would argue, no, it never was. You had a fortress and so on. But look how it has developed since 1972. So, what's the next? 1988, 2000, 2010. And if you look closely, I mean, we can redo it. It's not just that clusters are growing and become fatter, but you have all types of satellites being created all over the place. This is a self-organized complex system because there was no plan to develop Delhi like this. There is no plan for such an agglomeration. It just happened, driven by the people, by businesses, by authorities, of course, by military, and so on. It just happened like this. Now, I want to introduce another distinction that is between informal, we heard a lot about it, and formal settlement. That's Cairo. I mean, the formal settlements in Cairo date back 4,000 years or something, some of them, if you go to the old city of Cairo. But now you have a sort of an umbrella of informal settlements. These are not necessarily slums. There are many settlements now have been created by corruption, by the black market, whatever, rich people who just shirk regulations and things like that. It's a different story than what you have in Bangladesh, for example, or Nairobi, of course. But nevertheless, these are informal settlements. So the German Advisory Council in his report was more or less saying what are the archetypes of urban challenges in the 21st century. And of course, what we are used to is mature cities, Stockholm, Copenhagen, Berlin, and so on. How can we improve them to provide more sustainability? This is a luxury problem, of course. It's not a luxury problem really for the citizens, as we just heard, gentrification and so on. So you, of course, buy out and expel the low-wage people from the city center and then from each quarter after quarter. So it is. But compared to what you have in other parts of the world, it's still a luxury problem. No? The second is planned cities. I mean, in China, in India, everywhere, in Latin America, in Africa, you have cities in the pipeline right now. As a climate scientist, I have to tell you that if the currently planned cities would be built the way they are planned right now, with concrete and steel and so on, this alone would eat up half of the carbon budget left for holding the 2 degrees line, the Green Paris. So only if this is implemented, what is already planned, we lose probably 20 years we have left for holding the 2 degrees line. So clearly something has to happen there. And then finally, this was fortunately already explored in a panel before, because I think it's absolutely crucial. You have the informal settlements. We simply do not know whether in the future, when the world population rises to at least 10 billion people, that's the latest forecast, it can be 11 billion people, whether 1 or 2 or 4 billion people will live in informal settlements. So this is the biggest challenge of all. What can we do about it? And of course, you know, in Brazil, they tried Rio de Janeiro to just get rid of informal settlements, because there are these drug dealers there, and the military moves in, and the tanks and so on, but these people just move to a different part and then rebuild their networks, for example. So I guess the real challenge is, and that is a completely new challenge for architects and city planners in this age, help to create functional slums instead of trying to dream on ideal cities. And that is not just cleaning the streets that Saskia Sassen was referring to. It would mean help to build shanty towns, but in a way that basic needs of human beings are being covered. This is an unprecedented challenge in my view. And where our customers were? 3 billion maybe? We are not paying like the people who are paying or buying the dark towers of London, but these are human beings. So we need to explore this. So this is a sort of archetypical representation of the modern city now, consisting of 3 phases. I'm a physicist, but I'm not working for Goldman Sachs. I insist to tell you that, although I probably could have received a good offer in my heyday. But this is a 3-phase diagram of modern cities. So you have clearly planned parts. You have the mature parts, this is the green part in it, and when you have all these slums and informal settlements around it. And all over the world, 90% of the cities look like this, actually. So, people tried to get rid of all that mess in the 1930s. So, Le Corbusier, for example, came up with this beautiful, beautiful vision for Paris, because what you see in the upper left corner was his vision for Paris. So, fortunately, he failed, because I love Paris the way it is right now, although it was completely restructured by Haussmann about 200 years ago or 150 years ago. I love it much more than this thing. But the idea was the functional disentanglement of cities which have grown over the centuries, like London, like Liverpool and so on, like Paris or Berlin and the cities in the Ruhrgebiet. The idea was, okay, you work in a certain part, you live in a certain part, you recreate in a certain part, and let's disentangle that. And the answer is the automobile, of course, because with the advent of the automobile, yes, you hop onto the vehicle and just cover 10 miles, and when you do your wonderful sports or your cultural event. But this came with a big revenge, of course, so this was the functional disentanglement idea, because that was the result, the urban sprawl thing. So suburbia was invented, and in German you say, die autogerechte Stadt. I cannot translate it really. I mean, what does it mean? Is it the city which is just to cars? Which doesn't make sense in a way, but really this term was coined in Germany. And so the urban sprawl really happened, and the key to it was transportation, car transportation, individual transportation by automobiles. This is not the answer, obviously. So, if you look at real cities, and so I'm coming to my main subject, is whether you consider the Ruhrgebiet or Greater London or the Midlands, wherever you go, you find that cities, not planned cities, but cities self-organized, are fractal in growth and form. That means they do not fully cover the space, the area, but they are not points, of course. So they are somehow in between the dimension 0, of course, which would be the point, and the dimension 2. But they are actually well above in their dimension 1, so they are not linear structures. So let's just do a pedestrian explanation of what a fractal dimension is. Many of you will know it, but it's always fun to redo it. So the fractal dimension is defined. Okay, you take an entity, like here a square in the Euclidean plane in red. You can see it. Let's see whether this works here. It really works. So you look at this square here. And when you magnify this structure, you blow it up more or less by a certain scaling factor. In this case, it would be 3, so it gives you 9 squares, unit squares. And when the fractal dimension is simply defined, you take the logarithm, the natural logarithm of the numbers of copies created, 9 here, and divide it by the logarithm of the scaling factor, which is 3. And this gives you wonderful dimension of the area 2. But the Euclidean space is self-similar. You can blow it up and it recreates and it creates and generates copies of itself, perfect copies of itself. And we know this about the line and we know it about space. Just think about it, that the fundamental geometry of the world we live in is self-similar. This is not evident. But you can now look at weirder structures and then redo the fractal dimension calculation. So this is one of the simplest way of creating a fractal. It's the so-called Sierpinski carpet. And what do? You take a square and cut out, and you divide it into 9 subcopies, and then you cut out the middle square. But you do not stop there. From the 8 squares left, you do the same. So you cut out the middle square, and then you go on and on and on and on, ad infinitum, really. And now if I take the red entity here and blow it up by a factor of 3, you precisely, not just approximately, you precisely reproduce the original structure. It's perfectly self-similar. And we can calculate the dimension of that. And the dimension is logarithm of 8 over logarithm of 3. And Ina Schieferdecker can calculate this immediately. It's 1.89. So it's not 2. It's fairly close to the area, but not just. And the question is, what is the fractal dimension of cities? And as we have seen before, you of course have overlooked that, but now I come back to that. The fractal dimension is 1.7. This is a robust result. I mean, of course, you have cities where Islamabad is not fractal, for example, but in most settlements you end up with this fractal dimension of 1.7, really. Yeah? And the question is this, first of all, an interesting model for the future? In particular, when we look at the fundamental challenges which were introduced, for example, by Dirk Messner this morning. You know, in the German Advisory Council report, we came up with just 3 dimensions which are quintessential to how we would like to see the future development of urbanization in cities. So the first one was diversity. We call it in German Eigenart, the inclusiveness, Teilhabe, that means economic, social, governance inclusiveness, who owns the city, and finally, of course, sustainability with respect to climate change, to biodiversity, to many, many other things. Yeah? And the question is, of course, could be a fractal model where you do not work against fractality, as many city planners tried to do and always failed, but you work with fractality. Would that be a better model of the future? And the second question is, what would be the fractal dimension of it? Okay. The response of the real estate people, as we just learned here on the panel, is densification of cities. So, you have this 1.7, it's not 2. Let's go for the 2. Let's cram into each lacuna you have left in the city another building. Hopefully a high-rise building, 6 stories high, 10 stories high. Let's densify the whole space and end up with the fractal dimension of 2. Then you have a completely compact city. And of course, it's driven by speculation, we all know that. But there are many lofty and moral high ground arguments put forward, like, well, we reduce the greenhouse gas emissions, of course, because a dense city, you have less transportation and so on. By the way, if you look at real cities, it's not true. It's quite the other way around. But these are all the secondary arguments used, okay? But it's interesting that this debate is, I think, at least 20 years behind the discourse. Because while people argue in order to reduce greenhouse gases, let's build 1,000 Hong Kongs on this planet, the world has moved on and disruptive innovations were created. One of them is clearly renewable energy. I think personally that solar energy will trump everything else, also wind power, because it's scalable, yeah? You can apply it at each scale really, yeah? And will just win over everything. You have the digital revolution, clearly. So when we talk about jobs being created in the city center, my God, jobs will be created in cyberspace in the future. And the real capital, as Ina keeps saying, may be algorithms and data, and not factories and department stores and things like that. When we have completely novel materials, I talked to an architect yesterday. We are creating now, actually for Walmart, so that's a big company, buildings here in Berlin created from wood, but high-tech wood, which is resistant to fire and so on. And we do it by additive manufacturing, so the computer is building that. It's a completely new world, actually. Circular economy means you don't need new concrete, you just recycle the old concrete, which is all over the place. Urban farming, I alluded to that already. So we have all these disruptive developments right now. And the only answer we get from the real estate and the politicians and the urban planners is redensification, fill every gap which was left. This is 20 years behind the discourse, actually. So, my hypothesis, which I cannot support with any quantitative analysis, but maybe it's a nice research project. So first of all, on the right-hand side, so 2, that's the real estate, ideal city. The real fractal dimension is something like 1.7, as I have shown, and this is supported by data. I do believe that the postmodern fractal dimension should be smaller, actually. So the city should not be denser, it should be more scattered, it should be lighter, it should be more disentangled, really. Yeah? Not in the sense of Le Corbusier, but meaning that it will be much more self-similar in the future. You will have centers and subcenters of subcenters, but they are all connected by a huge network, which is assisted by the digital revolution, of course, and many other things. So that would be my hypothesis, how the structural development of the modern city will be. So defractal postmodern should be around 1.5. Okay, that's my conjecture. I already mentioned that architects have tried for centuries to work against fractality. So either coming up, with the square, rectangular city, the Romans already tried to do that, while the German villages were much more messy. And of course, when Le Corbusier and others think, so if we cannot just do the rectangular thing, we do the radial thing and all this. So I just referred to a few people who have really worked in this field, and one of them is actually here, Carlo Ratti. Where is he? Nice to see you. He has contributed to the development of theory. So I was a member of the Santa Fe faculty for quite a while, where Betancourt and Jeffrey West and others have developed this thinking. So it's a very nice article by Louis Betancourt and Jeffrey West in, what was it, Nature, 2010, A Unified Theory of Urban Living. I recommend it to everybody here in the room. It's physicists, but nevertheless, it's interesting. When there is with the scaling of human interactions, where Carlo Ratti is a co-author with city size, highly interesting stuff. When we talk about climate change, first of all, I do believe if the industrial metabolism and the domestic metabolism of modern cities is really driven by renewable energy, we will get rid of practically all greenhouse gases by 2050. And this is, by the way, absolutely necessary in order to hold the 2 degrees line. But also, we believe that something like the urban heat island effect, because 2 degrees warming is still a tall order, and you will have probably in inner cities when a rise of extreme temperatures by 5 or 6 or 8 degrees. In a lofty fractal structure, this would not happen, by the way. So you could avoid. And by the way, I think also that shocks of all types would be better absorbed by a lofty fractal structure, including refugees, for example, migrants. So what WBGU, the German Advisory Council, has argued, ultimately, we came up with our own vision. And this is, in a way, revitalizing the idea that has been put forward through 2,000 years, again and again, namely the polycentric approach. But this is not just a dreamer's proposition, because when you go back in history and look, at least in Europe, or in the old world, if you like, when and where the most productive societies happened and developed when it was clearly based on polycentric structure. So the old Mesopotamian cities, the Greek polis, of course, the Renaissance, and also in Germany, the most productive time in Germany was in the 19th century when provincial cities like Weimar and Jena became world famous because they hosted the most talented people. They didn't want to go to Berlin, no? They didn't want to go to Cologne or Frankfurt, no. They were sort of sitting and teaching and thinking in middle-sized or even smaller-sized cities. But if you think about polycentric structures, when 1,000 questions come to mind, of course, immediately. And I had the great privilege to work with Elinor Ostrom, who won the Nobel Prize in Economics, although she was not an economist. And she was a wonderful person. We were both members of the National Academy of Sciences, and so we published 1 or 2 papers together. And she did groundbreaking work, really, on polycentric systems for managing the global commons and the local commons and so on. So it's really an extremely fascinating question whether polycentric structures, I mean empowered polycentric structures, not where you have a federal government just doing all the regulations. If it's self-organized, whether polycentric structures are just a better government and a better governance option, clearly. It has not been explored, so maybe there is a direct relationship between good governance and the fractal dimension of a structure, another hypothesis of mine. And let me end, because we are living in troubled times, of course. And in 2015, we had this wonderful agreement in Paris. 2016 was a big, big backlash. Trump was elected, the Brexit happened, you had the coup in Turkey and so on. And there was this wave of national populist movement. And this year, things look much brighter, actually, but Donald Trump decided to pull out of the Paris Agreement, which in a way is just a fake thing, because it takes at least 3 years, and when the next election is coming along and he may not be president anymore, God forbid, but that's my personal view. But the interesting thing is, immediately after this announcement in the Rose Garden of the White House, there was actually a sort of hashtag, and when campaign went viral in the net, namely, "We are still in," an open letter signed by a number of states, like California, for example, universities, but in particular, practically all the mayors of the major and also middle-sized cities in the United States. So even if the federal government is willing to pull out of Paris and to just let the planet go down the drain, the cities of the United States will not allow that to happen. This is extremely encouraging. So it's in a way the beginning of the governance at the polycentric level. Thanks for your attention.